Guys, section B says answer true or false. Question 7. If f of x is equal to 2 minus 3x, then the derivative d by dx of f of x equal to 3, because the slope at each point is 3. If f of x is equal to this, then the derivative of f of x is equal to 3. Why? Because the slope of this function at every point is 3. That is not true. The answer here is false. It is false because the derivative of this function is negative 3. It's negative 3 and not 3. So this is supposed to be negative 3. This one is wrong. So the statement is false. Then number 8 says that the derivative of the function f of x equal to 3 root x is 3 divided by 2 root x. Well, let's find out if that is the derivative. So differentiating this function, we first of all have that we can express this as 3 times x to the power half. Then differentiating it, we simply apply the power rule of differentiation. We say bring down the power, so we have 3 times half. Copy the function and subtract 1 from that power. That's all. So simplifying this is 3 on 2 times x to the power half minus 1 is negative half. And of course, we can write this as 3 on 2 times 1 on x to the power half, because of this negative here. So we take it down as a fraction from loss of indices. And again, this is equal to 3 on 2, 1 times 1 on the square root of x. Since the power half means square root, this gives us 3 on 2 root x, which is equal to what they gave us. So from this derivative, we can conclude that the statement is true. So question 8 is true. Question number 9 says, integration by parts is called DAD because the technique only performs a part of the original integral. Well, the statement is false because all integration techniques perform the integral of the function completely. If you integrate a function and you don't complete the integration, then you have not done the work. So integration by parts does complete integration and not just partial integration. So this answer is false. Then number 10 says that the definition of the first derivative of a function f of x is f prime of x equal to f of x plus delta x minus f of x on delta x. Well, this derivative is also wrong. It's false. The first derivative of the function f prime of x is defined as the limit as this delta x tends to 0 of f of x plus delta x minus f of x divided by delta x. So you can see that in this definition, they did not include this part. They did not include it. Since they did not include it, it makes the definition wrong. Then number 11 says to find f prime of x when f of x is equal to 3x squared minus 2x all this to the power 4, one could use the chain rule. True. To expand, to differentiate this function, we can either apply binomial theory to expand this binomial, or we apply the chain rule to differentiate it. That means by the binomial theorem, we first of all expand before differentiating. By using the chain rule, we can differentiate directly without going through a long procedure. If I have to give the derivative of this function, it will be bring down the power, copy the function, subtract 1 from the power, and then multiply that by the derivative of the base. Differentiating this base gives us 6x minus 2. So this is the derivative of this function. That is 4 into 3x squared minus 2x to the power 3 times 6x minus 2. Question number 12. The equation of the tangent line to the curve f of x equal to x squared minus 4x minus 1 at the point, we have at the point 1, negative 4 is negative 2. Very good. The question is asking us that, telling us that the equation of the tangent line to this curve is negative 2 at this point. But that is not true, because negative 2 is a number, it's not an equation. So it cannot represent the equation of the tangent line at this point. But however, if they had told us that it was the gradient of that tangent line, then we could verify. Let's verify if it's the gradient of the tangent line at this point. For the gradient of the tangent line at that point, we simply differentiate the function itself. This gives us 2x minus 4. At this point, x is 1. So we have that at x equal to 1, we have the first derivative, which represents the gradient. We represent the gradient of the tangent line as we substitute 1 here. We have 2 into 1 minus 4, which is equal to 2 minus 4, which is equal to negative 2. So you see that the negative 2 is the gradient of the tangent and not the equation of the tangent itself. So this one is false. This question is false. Then number 13 says, in binomial theory, the evaluation of n combination 0 is not the same as n combination n. Well, this one is also false. It said it's not the same. This one is false, because actually they are the same. Let's see how. We know by definition, n combination r is defined as what? N factorial divided by n minus r factorial times r factorial. So n combination 0 will be what? N factorial divided by n minus 0 factorial 0 factorial. Simplifying is what? N factorial. N minus 0 is simply n, and then factorial 0 factorial is 1. So it stays out. Then you see that this can cancel this, and we have 1. And what about this one? N combination n is the same as n factorial divided by n minus n factorial n factorial. This gives us n factorial divided by n minus n is 0. So 0 factorial n factorial. But as we have seen already, 0 factorial is 1. So this one simplifies again to 1. Therefore, n combination 0 is actually the same as n combination n. So the statement saying that they are not the same is wrong. Question number 15. This question is telling us that this integral is equal to this. Well, let's verify if it is true. Meaning that what? Let's integrate this function and check if it gives us this. If it gives us this, then we can conclude that yes, this statement is true. But if we integrate and it doesn't give us this, we conclude that the statement is false. So, to integrate this function, we are going to use integration by parts because this is a product of two functions. And as one is increasing by integration, the other is reducing by differentiation. So, I will let my u to be equal to x, and I'll let my dv to be equal to e to the 2x. You can clearly see that differentiating both sides here gives me du equals to dx, and here integrating this gives me, integrating both sides gives me v equal to 1 on 2 e to the 2x. Now by integration by parts says that what? The integral of x e to the 2x dx is equal to uv minus the integral of v du. This gives us our u is x, our v is 1 on 2 e to the 2x minus the integral of v. V is 1 on 2 e to the 2x dx. That's our du is dx. Simplifying this, it gives us x into 1 on 2 e to the 2x minus, I take this out, I have the integral of e to the 2x dx. This gives me x into 1 on 2 e to the 2x minus, we integrate this one just like we did up here. So it gives the same thing. That is 1 on 4 or 1 on 2. We integrate this man, it gives us 1 on 2 e to the 2x plus the constant of integration, which is equal to x into 1 on 2 e to the 2x minus 1 on 4, because this is 2 times 2, e to the 2x plus k. That's our integral. And as you can see, comparing this integral with what the question gave, they are exactly the same. Hence, this statement is true. Question number 16. Question number 16 tells us that f of x is defined this way. The integral from 0 to 2 of f of x is most nearly equal to 2.7907. Well, to verify if this statement is true about the integral of this function, we simply need to integrate this function and check if it gives us that answer. Now, integrating this function, we see that the integral of f of x dx from 0 to 2 is actually the integral of f of x from 0 to 1.2 dx and from 1.2 to 2 of f of x dx. This gives us the integral from 0 to 1.2 of f of x. In this interval from 0 to 1.2, the function f of x is simply x. And in this other interval, it is x squared. So we have 1.2 to 2 of x squared dx. Integrating, this one gives us x squared on 2 from 0 to 1.2 plus this one gives us x cubed on 3 from 1.2 to 2. Substituting upper limits and lower limits and simplifying gives us, here we have 1.2 squared divided by 2 minus 0 squared divided by 2 plus, here we do the same thing, 2 cubed divided by 3 minus 1.2 cubed divided by 3. Simplifying these two results gives us 4.752 correct to 3 decimal places, which you see that is not equal to 2.7907, or even approximately it is not. Therefore, the statement is false. So I'm concluding that this is false. Alright guys, number 17 is telling us that the area under this curve from -1 to 0 is 2.5 square units. Well, to answer if it is true or false, we simply need to find that area. If it gives us this, we conclude that it's true, otherwise it is false. To find this area, we simply do what? Integrate the function from -1 to 0 within this limit. So we have 2x cubed minus 6x, all of this with respect to x. Integrating this gives us 2x to the power 4 divided by 4 minus 6x to the power 2 divided by 2. All of this from -1 to 0. Simplifying, you can clearly see that if we substitute, we have 2 into 0 to the power 4 divided by 4 minus 6 into 0 squared on 2. This is substituting upper limit, and then minus, we substitute lower limits as well. We have 2 into -1 to the power 4 divided by 4 minus 6 into -1 squared divided by 2. Alright, this is 0, this is 0. So 0 minus, here, -1 to the power 4 is 1. So it gives us 2 on 4 minus -1 squared is also 1. So this gives us 6 on 2. Simplifying this, we have 0 minus 2 on 4 is the same as 1 on 2 minus 6 on 2, which is going to give us 1 minus 5. That's negative 1 minus 5, 1 minus 6, sorry, which is -5 on 2. And this negative and this one cancels out, and we're left with 5 on 2, which is an improper fraction. Expressing as a mixed fraction gives us 2 and a half square units. So you see that the area we have found is the same as the one that they gave us. Therefore, this statement is true. Alright guys, number 18. Number 18 is telling us that the integral of this, or this integral, is equal to this. Is it true or false? Well, the answer here is that it is false. We don't even need to verify. The reason is simple. This was an indefinite integral, and therefore there needed to be a constant of integration. Since there was no constant of integration, it means that the answer is not totally correct, it's just partially correct. So the statement is false. Then number 19 says, if we have this equation, then differentiating the equation should give us this. Well, we cannot answer directly like the other case. So this time around, we have to actually differentiate this equation and check if it gives us this. To do so, we carry out explicit differentiation. That means we differentiate term by term everywhere. Differentiating this term with respect to x gives us 2x minus. We don't differentiate this one. This one is a product of two terms or two functions. We differentiate it by product rule. We keep x constant, we differentiate y, it gives us dy by dx. We then keep y constant and we differentiate x, it gives us 1. Then plus, we differentiate this one, we have 2x, which is equal to 3. We differentiate 3, it gives us 0. So this is 0. Now, our interest here now is to make the x the subject. We have here 2x and 2x. It gives us 4x. We take it across. We have negative dy by dx. If I expand this bracket, you understand? It gives us negative y is equal to negative 4x by taking the sum of these two across. Now, our interest is to make dy the subject. So I have negative x dy by dx is equal to, we take this y across, it gives us y minus 4x, and then we divide both sides by negative x, it gives us y minus 4x divided by negative x, which clearly you can see that it is not equal to the answer they gave us, y minus 2x divided by xy minus y. Hence, the statement is false. Question number 20 says that the integral of 1 on x cubed is equal to this. Well, let's verify. The integral of 1 on x cubed dx is the same as the integral of, we can integrate here by power rule. So I take this function up, it gives me x to the power negative 3 by loss of indices. Now you know how to integrate this. We take the function, add 1 to the power, and divide by the new power. And we get plus our constant integration. Simplifying this gives us x to the power negative 2 divided by negative 2. Of course, we can write it as negative 1 on 2 and then divided by x squared plus k, which of course is equal to what they gave us. Therefore, this statement is true, and it completes the solution of MATS 2108, the exam that came in 2019-2020.